whenever you entered this classroom, we had some discussions early on about how to calculate error. Whenever you go into the laboratory, it's frequent that you would make a measurement and compare it to what a calculated value should be. Those two values are rarely the same, so you would have to calculate what is the error associated with it. Whenever you get back a quiz grade or an exam grade, you will receive a percentage many times. And that percentage is your percent correct. Most teachers do not focus on how much you miss. In fact, they want to highlight how well you've done. So, whenever you receive that grade on your sheet, on your test exam, it's usually not referred this way, but I want you to think of it. It's your percent yield. It's the percent correct. So, if you were to have achieved a 50% error, you would have achieved a 50% yield. If you would have gotten an 86% error, you would have gotten a 14% yield. If you would have gotten a 75% correct, well then you would have had a 25% error. So the two values, percent error and percent yield, are always going to equal 100. And that's what I need you to walk towards with me as we understand what is a percent yield. A percent yield is merely the opposite or the complementary to the percent error. We have already discussed how to calculate a percent error, so let's begin our discussions with that. In a parallel universe, in 2014, you learned that the formula for percent error is right minus wrong divided by correct. Or, if you want to do correct minus wrong divided by correct, it doesn't matter because this error calculation is always in absolute value. You will always have a positive error. You won't have negative errors. It is possible statistically to be above a value in a laboratory or below a value in a laboratory, and then we would need to deal with positive and negative percentages. But for our purposes, we're going to stick to the fact that errors are always positive. Positive value. It's not a positive item, but a positive value. So what is the percent error in an example? If you have made 60 grams, but you are supposed the correct answer is 55, but in the lab you created 60 grams. What would be your error for this? Using this formula, what you would do is you would say correct minus wrong divided by correct gives you 9% error. Well, number 35 echoes that sentiment. If the percent error is 9%, what is called the percent correct?
Percent yield.
Percent yield. Yeah, it'd be percent yield, but what would be that value? 91%. You subtract 100 from it. This is your percent yield. Thank you, Matt Kearns. That is absolutely right. This is called percent yield. Now, we could stop our lesson pretty much right here because you're saying, okay, I already know how to calculate a percent error. All I have to do then is subtract it from 100 to figure out what my percent yield is. I'd be doing you a disservice, though, at that point, because there is actually a formula for percent yield, and I want you to be aware of that. So let's then continue our discussion with 37, where we will look at this formula. The percent yield formula is the amount produced, that's the wrong value, divided by the correct value, what you expected to happen. But in the laboratory, we're not going to use right and wrong, so you're going to have to understand the vocabulary that's going to be utilized. If it was the amount produced, it's the wrong amount, it goes on top. If it's the amount that you expected, if it's the correct amount, that's what goes on bottom. Wrong divided by correct gives you a percent yield, which is how much you are correct. The problem reads, given a lab, you make 87.8. Is that the correct value or is that the wrong value? If you make it in the lab, is that the correct value or the wrong value? That is the wrong value. You were supposed to produce 93.2. Here is the simplified way of doing this. Or you could have said 93 minus 87 divided by 93, and it would have given you then the percent error. Either way that you go about this, you're gonna get the exact same information. If it's 94% correct, how much is it wrong? 6% is exactly right. Thank you very kindly. So, number 39. You collect 96 milliliters, but you're supposed to get 93. Which one is the incorrect value? The 96 is what you produce in the lab. It goes on top. You divide by the 93. Here's one of those examples. Somehow, miraculously, I made matter out of thin air. I got 103% yield. What is my error on here? It's 3% error. That's exactly right. Somehow you're off, okay? I don't know what it is, but you have a 3% error in the wrong direction. You've got too much there. So my guess is that you probably weighed the initial amount incorrectly. But the way we will report this is that you had 97%, I'm sorry, you had 97% correct or 3% error, however you wish to view that. The yield is still 103%. You made 103% of what you were supposed to.
Pretty good.
Yeah, pretty impressive. I want to do that with my money. Last question. Let's say that you have 95%. You are given the yield in advance. 95% is the yield. You made 550 grams. Is that the incorrect or is that the correct value? That is the incorrect value. So now we have a situation where we're solving for what you were supposed to make. What is the correct value underneath? You are solving for that x. Oh my gosh, this sounds like algebra, solving for the denominator. It's exactly what it is. You need to think about this in terms of a cross multiplication. It would be 550 over x equals 0.95 over 1. What operation would you, mathematical operation would you need to solve for that x?
Multiplication.
You would do a cross multiplication. So you would do x times 0.95 equals 550. And how now do you get that x by itself? You would divide. So it's almost, no, it's exactly like you know every single possible way that I can ask you a percent yield question.
Couldn't we just do 550 divided by 0.95? Or do we...
Yeah, you could.
Yeah, something.
Dang, that's smart.
But if you know how to do that right away, that's fine. But the rest of us may want to rely on the formula. But if you have the foresight to understand how this is going to end up, then go for it. I'm not going to dissuade you because you've got the right answer. So what we did is 550 divided by 0.95, and you end up with 578. That's how much you should have produced. You should have produced 578.9 grams. You didn't. You produced 550 grams. You should have produced more. How stinking eloquent and simple is this? All right. Pretty sickening simple. All right, that's the